Tell me about a time you designed an API introduction. This is an important behavioral and technical interview question for software developers, backend developers, full-stack developers, and senior engineers. Interviewers ask this question to understand how you gather API requirements, how you design endpoints, how you define request and response models, how you handle validation, how you design error responses, how you think about security, how you support scalability, how you document and test APIs. This question is especially important for Java developers, backend developers, full-stack developers, senior software developers, API developers, microservices developers, team leads, system design interviews. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section, because interviewers want to understand your API design thinking, not just that you created an endpoint. Question: tell me about a time you designed an API. Example 1. Designing a customer search API situation. In one project, the business team needed a new customer search feature. Users needed to search customers by name, email, status, and date range. The existing system had customer data, but there was no clean API that supported flexible searching. Task: I was responsible for designing and implementing the backend API for customer search. The API needed to be easy for the front end to use, efficient for large datasets, and safe for production usage. Action: I started by clarifying the requirements with the product owner and front-end developer. I identified the main search fields: customer, name, email, customer status, created date range, page number, page size, sort field, sort direction. Then, I designed the endpoint. Get API customers search. I used query parameters for filtering and pagination because this was a read operation. Example: get API customers search status equals active, page 0, and size 20, and sort created date desk. I designed the response DTR to include only the fields required by the UI. The response included: check customer ID, check customer name, email, status, created date, pagination metadata, total elements, total pages. I also added validation rules. For example, check maximum page size, check valid status values, check valid date range, check valid sort fields. For error handling, I used a standard error response format with error code, message, timestamp, and correlation ID. To improve performance, I added pagination, proper database indexes, and selected only required fields instead of returning full customer entities. I also added unit tests, integration tests, and OpenAPI documentation. Result: the API was delivered successfully and integrated with the front end. The customer search page became faster and easier to use. Pagination and filtering made the API scalable for larger datasets. The API design pattern was later reused for other search endpoints. Why this answer works? This answer is strong because it shows: check API requirement gathering, check endpoint design, check pagination, check filtering, DTO design, validation, check performance, documentation. Example 2. Designing an API for creating orders situation. In one application, we needed to add a new feature that allowed users to create orders from the web application. The backend needed to validate the request, save order data, and return a clear response to the front end. Task: I was responsible for designing the Create Order API and making sure it was reliable, secure, and easy to integrate. Action: I started by understanding the order creation workflow. I reviewed required order fields, customer information, product details, payment status, validation rules, duplicate order prevention, error scenarios, audit requirements. Then I designed the endpoint. Post/API orders. The request body included customer ID, list of items, quantity, shipping address, payment reference, request ID for idempotency. I added validation for check required fields, check valid customer ID, check valid product ID, check positive quantity, check valid address, duplicate request ID. I also designed the response carefully. The response included click order ID, click order status, click created timestamp, confirmation message. Since order creation could accidentally be submitted multiple times, I added idempotency using a unique request ID. If the same request was submitted again, the API returned the existing order response instead of creating a duplicate order. I also added proper error handling for validation failures, duplicate requests, unavailable products, and unexpected errors. Finally, I added unit tests, integration tests, and API documentation. Result: the order creation API was delivered successfully. The front-end team integrated it without major issues because the request and response contracts were clear. The idempotency design prevented duplicate orders during retry or double-click scenarios. Why this answer works? This answer is strong because it shows post-API design, request-response contract, validation, idempotency, duplicate prevention, error handling, business reliability. Example 3. Designing a file upload API situation. In one project, users needed to upload documents through the application. The original process was manual, and the business wanted users to upload files directly from the web interface. Task: I was responsible for designing the file upload API and making sure it handled validation, security, metadata, and upload status properly. Action: I started by gathering requirements. I clarified. Quote, allowed file types. Quote, maximum file size. Quote, required metadata. Who could upload files? Quote, how files should be stored. Quote, whether files needed virus scanning. Quote, how users would check upload status. Then I designed the endpoint. Post API documents.upload. The API accepted multi-part file data and metadata, such as document type and related business ID. I designed the backend flow as user uploads file, API validates user permission, API validates file type and size, file is stored in object storage or file storage, metadata is saved in the database, upload status is returned to the user. I added validation for count, file size, file extension, content type, required metadata, user permission, duplicate file name when applicable. For the response, I returned document ID, circle, upload status, file name, uploaded timestamp. For security, I made sure users could only upload files for records they had permission to access. I also avoided exposing internal file paths in the API response. Result: the file upload API was delivered successfully. Users were able to upload documents directly from the application. The API was secure, validated file input properly, and stored metadata in a way that supported future document retrieval. Why this answer works? This answer is good because it shows check, file upload design, check, security, check, validation, metadata storage, check, storage separation, check, user permission handling. Example 4. Designing an API for updating user profile situation. In one application, users needed the ability to update their profile information. The front end needed a clean API to update profile details and display validation messages clearly. Task: I was responsible for designing the Update Profile API and making sure it handled validation, authorization, and partial updates properly. Action: I started by reviewing the profile fields and identifying which fields users were allowed to update. Then I designed the endpoint. Patch, API, users, user ID, profile. I chose patch instead of put because the front end needed to update only selected fields, instead of sending the full profile every time. The request body supported fields such as check, display name, phone number, address, notification preferences. I added authorization logic so users could update only their own profile unless they had an admin role. I added validation for phone number format, maximum field lengths, allowed preference values, restricted fields, invalid user ID. I also designed a clear error response for field-level validation issues. For example, if phone number format was invalid, the API returned a field-specific validation error. I added tests for normal updates, partial updates, unauthorized updates, invalid fields, and missing users. Result: the API made profile updates simple for the front end. Users could update specific fields without sending the full profile. Authorization and validation helped protect user data and prevent invalid updates. Why this answer works? This answer is strong because it shows patch API design, partial update handling, authorization, validation, field-level errors, front-end friendly design. Example 5. Designing a paginated transaction history API situation. In one financial style application, users needed to view transaction history. The dataset could grow very large, so returning all transactions in one response was not scalable. Task: I was responsible for designing an API that allowed users to retrieve transaction history efficiently and securely. Action: I started by clarifying the front-end and business requirements. Users needed to filter transactions by question, account ID, check, date range, transaction type, status, page number, page size, sort, order. I designed the endpoint. Get API accounts transactions. Example: get API accounts 123 transactions. From date is 2026-01-01, to date is 2026-01-31, page 0 and size 25. I added authorization so users could access only transactions for accounts they were allowed to view. I added validation for LAX, valid account ID, date range, maximum page size, valid transaction type, valid sort field. To make the API scalable, I added pagination and stable sorting using transaction date plus transaction ID. This prevented missing or duplicate records between pages when multiple transactions had the same timestamp. I also designed the response with pagination metadata. The response included transaction ID, date, amount, type, status, description, current page, total pages, total records. Result: the transaction history API was scalable and secure. The front end could load transaction history page by page. The stable sorting prevented inconsistent pagination results. Why this answer works? This answer is strong because it shows secure API design, pagination, filtering, stable sorting, large data handling, financial style use case. Example 6. Designing an API for messages between user situation. In one application, users needed to send messages to another user or business owner. The system needed an API for sending messages, retrieving conversations, and replying to messages. Task: I was responsible for designing the messaging APIs in a way that supported future real-time communication. Action: I started by breaking the feature into core API operations. Cook, send message, get conversation list, get messages in a conversation, mark message as read, reply to message. I designed endpoints such as post API conversations / conversation ID, get API conversations, get API conversations at conversation ID, messages page 0 and size 20. Patch API messages, message ID, read. For sending a message, the request included see receiver ID, message content, optional attachment reference. I added validation for check empty message, check maximum message length, check valid receiver. Check, blocked user scenarios. Check, permission to access conversation. For scalability, I designed message retrieval with pagination because a conversation could have many messages. For future real-time support, I kept the REST API clean and designed the message model so WebSocket events could be added later. I also added created timestamp, read status, sender ID, and conversation ID to support message display and notifications. Result: the messaging APIs supported sending, replying, and retrieving messages cleanly. The frontend could integrate the APIs easily. The design also left room for WebSocket-based real-time messaging later. Why this answer works? This answer is good because it shows capital P, API decomposition, REST endpoint design, messaging model, pagination, permissions, future WebSocket support. Example 7. Designing an API for report generation situation. In one project, business users needed to generate reports based on filters such as date range, status, and category. Some reports took longer to generate, so the API needed to support both request submission and status tracking. Task: I was responsible for designing the report generation API so it could support long-running report jobs reliably. Action: I started by reviewing how long reports could take and whether users needed the results immediately. Since some reports could take time, I avoided designing it as a simple synchronous API. Instead, I designed an asynchronous report flow. The endpoints were post API reports, submit report generation request, get API.reports-report ID status, check report status, get/API reports/report ID download. Download completed report. The post request included check report type, date range, filters, output format. The response returned check report ID, status, submitted, timestamp. The backend saved the report request, processed it asynchronously, and updated the report status. I added validation for check valid report type, check allowed date range, check valid filters, check user permission, duplicate report request if applicable. I also designed statuses such as pending, processing, completed, failed. Result: the report generation API handled long-running reports without causing request timeouts. Users could track report status and download the file when ready. The design improved reliability and user experience. Why this answer works? This answer is strong because it shows asynchronous API design, asynchronous long-running job handling, status tracking, report download flow, validation, user experience thinking. Example 8. Designing a public API with versioning situation. In one project, we needed to expose an API that could be consumed by external clients. Because external clients depend on stable contracts, we needed to design the API carefully. Task: I was responsible for designing the API contract with versioning, clear request and response structures, and backward compatibility in mind. Action: I started by defining the API contract with the consumers. I clarified safeness, required fields, optional fields, response format, error format, authentication method, rate limits, backward compatibility requirements, documentation needs. I designed the endpoint using versioning. Get API v1 products product ID. I used DTOs instead of exposing internal entity models. I also designed a standard error response with error code, xMessage, xtimestamp, correlation ID. For backward compatibility, I avoided removing or renaming existing fields once the contract was published. If a future breaking change was needed, it would go into a new version such as /API/v2. I also created OpenAPI documentation and shared sample requests and responses with the consumers. Result: the external clients were able to integrate with the API smoothly. The versioned design reduced the risk of breaking existing clients. The documentation helped reduce back-and-forth questions during integration. Why this answer works? This answer is strong because it shows, comma, public API design, comma, versioning, comma, DTO usage, comma, backward compatibility, comma, documentation, external consumer thinking. Best short answer version. If you need a short interview answer, you can say, in one project, I designed a customer search API for a new front-end feature. Users needed to search customers by name, email, status, and date range. I was responsible for designing the endpoint, request parameters, response structure, validation, and performance approach. I started by clarifying the requirements with the product owner and front-end developer. Then I designed a get endpoint with query parameters for filters, pagination, and sorting. I used a response DTO that returned only the fields needed by the UI, instead of exposing the full database entity. I added validation for page size, valid status values, date range, and allowed sort fields. I also added pagination, stable sorting, database indexes, standard error responses, and OpenAPI documentation. As a result, the front-end team integrated the API easily. The API handled larger datasets efficiently. And the same design pattern was reused for other search APIs. Common mistakes to avoid. 1. Saying only I created an endpoint. Bad answer. I created a REST endpoint for customer search. Better answer. Explain the endpoint design, request parameters, response DTO, validation, error handling, security, testing, and documentation. 2. Exposing database entities directly. Bad answer. I returned the entity from the API. Better answer. I created response DTOs, so the API contract was separate from the internal database model. 3. Ignoring pagination. Bad answer. The API returned all matching records. Better answer. I added pagination and maximum page size to keep the API scalable. 4. No error design. Bad answer. Errors were handled normally. Better answer. I used a standard error response with error code, message, timestamp, and correlation ID. 5. No security. Bad answer. Anyone could call the endpoint after login. Better answer. I added authorization checks so users could access only records they were allowed to view. Best practices for answering this question. Use the STAR method. Explain the business need. Explain the API users. Mention endpoint design. Mention request and response DTOs. Include validation. Include error handling. Include security and authorization. Include pagination for large data. Mention testing and documentation. Explain the result and impact. What interviewers are looking for. Interviewers want to see whether you can C. Design clean REST APIs, understand business requirements, create stable contracts, avoid exposing internal models, handle validation properly, design useful error responses, think about security, support scalability, document APIs clearly, collaborate with front-end and consumers. For senior roles, they also want to see check API versioning, backward compatibility, idempotency, async API design, observability, rate limiting, API governance, long-term maintainability. Strong words to use in your answer. You can use words like designed, clarified, defined, validated, documented, secured, paginated, versioned, standardized, tested, integrated, optimized. Example: I designed the API contract, defined request and response DTOs, added validation and authorization, documented it with OpenAPI, and tested it with the front-end team before release. Good API design topics you can use. Depending on your experience, you can talk about customer search API, create order API, file upload API, update profile API, transaction history API, messaging API, report generation API, public versioned API, authentication API, notification API, payment API, document download API, admin management API. Final summary. Tell me about a time you designed an API is an important interview question. for software developers and backend engineers. The best answer should include: check what problem the API solved, who used the API, your responsibility, endpoint design, request and response structure, validation, security, error handling, scalability, testing, documentation, result. Good examples include Customer Search API, Order Creation API, File Upload API, Profile Update API, Transaction History API, Messaging API, Report Generation API, Public Versions API. The strongest answers show API design thinking, clean contracts, security, scalability, and collaboration.